Hi, my name is Emmanuel, and I'm going to present the DB-BERT system for automated database tuning. The particularity in DB-BERT is that it mines tuning hints from text documents and uses them in order to find good configurations for a user-defined workload and performance metric. If you take a database management system like Postgres, for instance, you typically find lots of text documents on the internet which recommend specific settings for specific parameters in specific situations. And that starts, for instance, with the database manual, where here we have a hint about how to set the shared buffers parameter, which is we should use 25% of the available main memory. And you also find blog entries, you find discussions in forums like the Stack Exchange forum, for instance, and all of this text contains information that can be useful for a database tuning. So the DB-BERT system exploits this kind of information, and the first thing that you need to do is to select a collection of text documents that it will exploit for tuning. And here I have selected a collection of 100 text documents that have been automatically downloaded from the results of the Google query Postgres performance tuning. All right. So now if I want to use this for a specific system and workload, then first of all, I should tell DB-BERT which system properties we have, because some of those tuning hints, they are relative. For instance, they recommend a certain ratio of available RAM to use. And in order to resolve those hints, the system needs to know how much RAM is available in total. So here we have those system properties. They have already been preset. Besides that, I have to configure the database access, because we will be running an example workload to tune on with specific configurations on a specific database and then measure the resulting performance in order to find a good configuration. So yeah, the details about the database. And finally, I need to select what I want to tune for. First of all, I have to select the performance metric. Here we're selecting runtime, but I could also rather try to maximize throughput. And here I have the benchmark that we're tuning for, which actually contains the TPCH queries. So after all that, we can start the tuning process by clicking here. And so the first thing that happens is that DB-BERT analyzes the input text in order to automatically extract interesting tuning hints. And as the name DB-BERT already suggests, it uses the BERT transformer model for language analysis, as well as some of the follow-up models such as Roberta or BART. So now DB-BERT is going through those documents. It is looking for recommendations for how to set the specific parameters. It's not going to exactly follow those recommendations, because later it might try to vary those recommendations, and it will try to combine them in different ways. But for the moment, it is just analyzing the input text in order to extract those tuning hints. So this is taking a couple of seconds. It applies the BERT model to different passages in those input documents. And now here we have the extracted tuning hints. For instance, here you see a text that appeared in one of those documents, which seems to contain tuning hints. And here DB-BERT automatically extracts the configuration parameter that is mentioned in this text, which is the shared buffers parameter. It also extracts the recommended value, which is 25%, and it classifies the hint. And here we believe that the hint recommends a ratio of RAM to use, and that inference is accurate in this case. All right, so now we have extracted the tuning hints. And in the next stage, DB-BERT uses reinforcement learning in order to combine those tuning hints into database configurations that it tries out, meaning that it runs the TPCH workload here and measures the resulting performance. So reinforcement learning means that we make sequential decisions, and those decisions are associated with a tuning hint. So here in this table, we see an overview of the decisions that DB-BERT is making. And I'm making that a little bit larger. So here we start with a hint about the shared buffers parameter. And you might notice that here we are considering those tuning hints not in the order in which we found them in the documents, but rather DB-BERT uses a heuristic in order to prioritize those hints. And one of the factors that play a role in this priority is how frequently the corresponding parameter is mentioned in the input text, because more frequently mentioned parameters tend to be more important. And for each of those tuning hints, we have to make a couple of decisions via reinforcement learning. So here, first of all, when translating this tuning hint into a recommended value, since it recommends 25% of available RAM, and we have 8 gigabytes of RAM available, the recommendation would be to set it to 2 gigabytes of RAM. Now, DB-BERT can decide to deviate from those recommendations because sometimes they are not true, sometimes they don't quite apply for the benchmark and tuning metric that we are interested in. So in this case, DB-BERT decides to take a value that is a little bit lower than the recommended one by factor 0.5. And also we have different hints about the same parameter from different sources, and those different hints can be in conflict with each other. Here, for instance, we have multiple recommended values for the shared buffers parameter. In order to resolve those conflicts, DB-BERT assigns a weight to each of those hints, meaning how much it will count when aggregating recommendations from different sources into one common value. And here for the first hint, we assign a relatively high weight of 16. Now, then trying to set this value, it turns out that the database system accepts the value setting. So here accepted is true. And that results in some first reward collected by DB-BERT, because in reinforcement learning, the goal is always to maximize accumulated reward. And a first component in our reward function is a reward for successfully changing a parameter to some value, and that is the case here. So A reward is assignment reward, and there's also a column for P reward, which means performance-related reward, because DB-BERT also obtains rewards for choosing configurations that result in performance improvements on the example workload compared to the default settings. But evaluating the full workload, in this case TPCH, can take quite a while, so we don't want to do this after each hint. So in this case, a DB-BERT only evaluates the sample workload every 10 hints. So it will first of all process a set of 10 hints, and then it will aggregate those recommendations into a few configurations to try out. And here, based on the reward that I see here, that seems to have worked because it was a positive reward. So those settings have apparently improved the performance. If you want to get more insights into which settings DB-BERT has tried out, we find it in this table over here. And as you see here, DB-BERT has tried out a setting which assigns the max connections to something of a little bit more than 100 and shared buffers to about 500 megabytes. And that already reduces the runtime by about 2 seconds. And here another configuration assigns higher values for both of those parameters, and that decreases execution time even more. So within something around 2 minutes of tuning time, we have already managed to reduce the execution time by about 1/4. And please note that here we had not to select a small subset of parameters to tune, because Postgres has hundreds of tuning parameters, but DB-BERT found out automatically which parameters are important by analyzing the input text, and it also extracted some suitable values for those parameters from the input text. So here we are gaining an advantage by integrating additional information that we extract from text documents. That's the idea of DB-BERT. Here you see a short demo, but I'm happy to show you a longer demo in Philadelphia.